Good evening. Today I have decided to discuss the properties of periodic functions and their graphs. This is a very common topic in your syllabus where you can solve many problems with the help of concept of periodic functions. And if you know that it is periodic function, that over a fixed interval its graph will be repeated. Okay, so the first thing regarding periodic function, I have to say that it is a type of function whose graph can be repeated. Okay, so if a function repeats its nature again and again after a fixed interval, then we refer it as a periodic function. Mathematically, for a periodic function, there exists at least one positive real number. Don't say integer, because integer may not occur always. Positive real number t independent of the variable x, such that f of x plus t will be equal to fx for all x. X is an element from the domain of the function, and the function fx is said to be periodic. For example, if you go through the function sin x, if you see the graph of sin x, you all can see that the graph repeats over a fixed interval, although because of lack of space I couldn't draw for a long range, for taking a long length of interval. This I am going to explain by taking two functions sin x and cos x. You all can see that in the interval, suppose I have taken 0 to 2 pi or minus 2 pi to 0. Say 0 to 2 pi, sine function, the graph nature is same as minus 2 pi to 0. So if you continue this manner, 2 pi to 4 pi, that part also will be repeated. So it is said to be a periodic function and of period 2 pi. Similar is the case for cosine x. This blue curve is cosine x. This graph also over the interval 0 to 2 pi. See, 0 to 2 pi, the nature will be same as minus 2 pi to 0. So this is a periodic function and it has period 2 pi over there. So sine function, cosine function, both are periodic functions and they are of period 2 pi. If I go by this tan x, no, this one cot x function. Graph of cot x function, if you see, this is also a periodic function. Here also the graph going to be repeated. If you see the nature of the graph, 0, x equal to 0 means y-axis to x equal to pi. The nature of the graph you can see from pi to 2 pi, same nature is repeated. This is true for all periodic functions. Over a fixed interval, the graph you see that will be repeated in the next length of interval. So whatever you find from 0 to pi, pi to 2 pi, it is going to be repeated. 2 pi to 3 pi, it is going to be repeated. These are called periodic functions whose graph will be repeated. I think all of you understand. Now let us go for another example where I will discuss periodic function property as well as the nature, that how it is repeated, and another thing, the period I would like to say will be a unique quantity over there. You all can see that this is the graph of tan x, which I have explained before. This in the graph of tan x, all of you can see that it is repeating from minus pi by 2 to pi by 2. Here if you go from this minus pi to pi by 2, the nature of graph same as that from pi by 2 to 3 pi by 2. So this is periodic, of course. Length of the period is this value minus this value, that is pi. In the previous example, sin x or cosine x, the period was 2 pi. Here the period going to be equal to pi. This is a periodic function. If anybody says that the graph I am getting from minus pi by 2 to 3 pi by 2, these two parts will be repeated, okay, you are true. If somebody says that it is from minus pi by 2 to 5 pi by 2, whatever I am getting, that repeated, that is also okay. So periods are not all fundamental. Period, here it is true for pi as well as true for 2 pi, 3 pi, 4 pi, 5 pi, for all these it is well defined. But remember, period means the fundamental thing. If it is period t once, then period will be 2t, period will be 3t, 4t, all these are available, but we will take the fundamental one only. So period of the function going to be equal to t, that is equal to pi in this case. It may be for 2 pi the graph remains the same, for 3 pi also graph remains the same, but we will consider the fundamental only. There are some functions which are not periodic, the graph will never be repeated. Okay. One thing you have to remember, the previous example or this example, for a periodic function domain will be infinite. For finite domain it is not possible. It can never be periodic if domain is finite. Here domain is finite, but still this is not periodic because the graph of this function will never be repeated. It continues this manner, it goes up to infinity. This is not a periodic function. Okay. Let us see another one, that is sine root x. Is this a periodic function? Sine root x, if you go by numerical calculation, if you take a period t over there, then it will be sine root over x plus t equal to sine root x. If you take the general solution and start simplifying it, then you will not get the value of t, which is a positive quantity. You will find t is going to be 0 over there. Here I am showing you how the situation arises for sin x. First, sin x obviously it has fixed period because the graph repeats. If you go for sine root x, I make sin x off over there. Sine root x function, this graph will not be repeated. Okay, I am just zooming out. See, this graph can never be repeated. Nature of the graph is not remaining the same, so this cannot be periodic. Sine root x from graph, it is obvious that it is not periodic. Okay, let us bring it back to the original state. Go for zoom in option. Okay, now for this graph, sine root x is not periodic. If we go for root x, this function also will never repeat. This is also not periodic. If we go for y equal to cos of root x, this is also not periodic because cos of root x graph, if you plot, this is just zoom out. Root x not periodic, sine root x not periodic, cos root x, if you see, this also, see, cos root x is very close here, close to 1, this is also not going to be periodic. Now, let us go for next one. That period of a function fx is known. If it is t, then it can be shown that period of this function of the form f of bx plus c, this will have period t by b. If fx has period t, then y equal to f of bx plus c will have period t by b. I am showing you with some example here. I have taken the graph of fx equal to, say suppose I am taking fx equal to sin x first. What is the period? All of you can see that the period going to be 0 to 2 pi, that is 2 pi. Here minus 2 pi to 0, that is also 2 pi. So everywhere 2 pi to 4 pi, see the graph repeats. So period, the fundamental period is going to be 2 pi. Now let us see for sine 3x. I have changed x to 3x. See what is the period going to be. Here is 2 pi. We are going to prove that in case of fx equal to sine 3x, the period is 2 pi by 3. How? Just check. This one I am making off. This red one, this one has period 2 pi. This is sine x graph. That is given. Now I am making this one off, going for sine 3x. Sine 3x function, you observe what is the period here. The graph repeats from what interval to what interval. If you take this full cycle, then the length is going to be 2 pi by 3. Okay, this period of sin x was 2 pi. Sin 3x period is going to be 2 pi by 3. The nature of the graph, you take this to this interval is going to be 2 pi by 3. Okay, that point, that coordinate, if you take this point of intersection, this to this length will be 2 pi by 3. This to this length will be 2 pi by 3. Everywhere it is going to be 2 pi by 3. So it will be that only. Now if we plot it for sine 3x plus 3, I have increased. There also it is passing through the same point. Period will remain 2 pi by 3. If we have taken 2 sine 3x plus 3, I have magnified, then also see passing through the same point. So period will remain the same. So if a function fx has period t, then if the function is of this form, that ax or ax plus b or some constant into f of ax plus b, the period will be t by a. Okay, coefficient of x, coefficient of variable, that will go to the denominator. This is going to be the period. Now let us go for period of mod sin x and mod cos x. If we find the period of sin x, as it is already told you, sin x or cos x, they have period 2 pi each. What about mod sin x or mod cos x? I am going to show you the graph where you will find that if sin x has period, see sin x function. Now I am going to plot mod sin x. What is the period here? In what interval the graph is repeated? I am telling you once more. That sin x period, you observe, sin x period is what? 2 pi. Now make sin x of mod sin x. What is the period? Length of this thing, minus pi to 0 or 0 to pi, going to be repeated. So period going to be 2 pi by 2, that is equal to pi. What about the function cos x? What is the period of cos x? Just we have seen cos x has period 2 pi. Mod cos x will be period what? See, this is again going to be equal to 2 pi by 2, that is equal to pi. Because the nature of the graph repeats over interval pi. So it is period pi only. Let us go for sin mod x. Is it periodic? Is it a periodic function? No, the nature is changed here. This sign nature will not be there from minus pi by 2 pi. So it cannot be periodic. See for tan x. Tan x graph is this. This is periodic. Length of period minus pi by 2 pi by 2 or pi by 2 to 3 pi by 2, length is pi. What happened to mod tan x? What is period here? Again see the length is pi. So you cannot find a general rule that by saying if sin x has period 2 pi, mod sin x has period pi. Similar is the case for cos x, but it may not be true for other trigonometric functions. Here it will remain unchanged for mod tan x. This you make one observation here. Now let us go for the function sine to the power nx, cos to the power nx, sec to the power nx. If n is odd, all these have period 2 pi only, that I am going to prove with the GeoGebra. If n is odd, then sine to the power n, cos to the power n, cosec to the power n, sec to the power n, they all have period 2 pi only. Okay, but later on we will see, just see this one first. Make all these off first. I am going to show you for sin x first. Okay. Then sin x has period 2 pi, all of you know. What about for sin square x? I am plotting here only. How does sin square x pass? See, sin square x is this. What is the length of interval here? Sin square x. This will have period. This has period minus 2 pi to 0 or 0 to 2 pi, that is 2 pi. But for sin square x, this green curve, it has period pi only. For this interval, it is going to be repeated. What about sin cube x? Here in the graph, I have sin x and sin cube x. See, the nature is repeating in a length of interval 2 pi. For sin x, okay, I'll keep sin x. Sin x. Yeah. Sin x graph and sin cube x graph. Sin square x, we have seen that period will be pi if sin x has period 2 pi. Here I am showing you sin cube x has same period as that of sin x. In fact, this is true for sin to the power 5x, sin to the power 7x. When the index is odd, the period of sin x and sin to the power nx will match. But if it is even, it will become half. Similar is the case for sin to the power 4x and sin square x. I am taking these three. That you will find better. See, all of them have even part. They are passing through the same point, sin x, sin square x, sin to the power 4x, even parts. If sin x has period 2 pi, they all have period pi only. Just a minute. This is sin x, blue one sin x, period 2 pi. This one, green one, is sin square x, period is pi. This one, this maroon one, it is period, again see, over the interval pi. So if the index n become even, then sin square, sin 4, sin 6, they all have period, same period over, that period will become half in those cases. But if index is odd, then period will have the same value. So for even index, it is half. For odd index, it will be same. Let us check in one more case. Take tan x. Graph is there. Then take tan square x. What is the length of period here? After what length it is being repeated? The same thing. Then you take tan cube x. See, in what length it is going to be repeated? Minus 3 pi by 2 to minus pi by 2. It has same period that of tan x. You cannot change it. There it is halved, there it will be the, in this case it will be same. Now keep tan x, tan square x and tan to the power 4x. See, they all have the same period. Okay, the length of the period equal to pi in this case. And I am keeping these three for your practice: cos x, cos square x, cos cube x. So when index is even, then it is going to be halved, but if it is odd, then it will remain the same. Now let us go for this thing. So this is already explained for even odd. I have done it. I am not going to do it again. This odd even also done again. Here. Now period of fractional part function. This is very interesting to note. Fractional part function you have plotted, but you have not ever thought about this. That its period this term may arise for fractional part. Fractional part graph, if you observe, then see it is be repeating after a length of 1 unit. So its graph shows that repetition occurs after a length of 1 unit. So frac x part has period 1 unit. Thank you. See you.